Lesson 5.1, Monomials. First of all, let me define what a monomial is or review what that is. Monomial is a single term. Okay, mono meaning one. You can obviously have coefficients and more than one variable, but a monomial is a single term. What we're going to look at here is simplifying an expression containing powers, and that means to rewrite the expression without parentheses or without negative exponents. So you have to write it with positive exponents. If you look at this first example here, you're multiplying two monomials together. If you look right here, we have 3x cubed y squared, and it's multiplied by the monomial negative 4x squared y to the fourth. And again, this is the example from the book, but basically what you're going to do is you're going to end up multiplying the 3 times the negative 4, okay, which gives you negative 12, so you multiply your coefficients, and then you are multiplying x cubed times x squared, which is going to give you the x to the fifth, and then you are multiplying the y squared times y to the fourth, and the product rule says you add exponents there, so that's going to be y to the sixth. So again, if you put that all together, you're multiplying your coefficients. 3 times negative 4, which is negative 12, and then you have x to the fifth, adding the exponents on your variable of x, and then you have y to the sixth, adding your exponents on the variable y. So that would be your answer when you multiply those two monomials together. Okay. Just some key concepts here. Again, this is kind of review of the product rule that we just used there. Basically, it says add your exponents. That includes when the numbers are bases. If you have 4 squared times 4 to the ninth, the base does stay a 4, which is a common mistake, but you do add the exponents. And then if the base is a variable, obviously the base stays that variable. Okay. When you're dividing, this rule down here is that you subtract exponents from top to bottom. So for instance, if you have 5 to the third over 5 to the first, remember this 5 on the bottom here, right here, is just a 1, so it'd be 5 to the 3 minus 1 power, or 5 squared. If you have x to the seventh divided by x to the third, subtract top to bottom, so it's x to the fourth. So just to give you a couple more examples there. Those aren't in your notes. Okay, if you go to example 2 here that we have, if you look at, you have p to the third divided by p to the eighth. Okay, so when you're dividing, you subtract exponents, and that's what they're showing right here, which leaves you with p to the negative fifth. You subtract from top to bottom. That's one way of looking at it. Now you have to write with exponents positive. So remember this, that when this is really over 1. Remember, to make an exponent positive, you move it to the opposite part of the fraction, so in this case down. And on the bottom, we would have 1p to the fifth, or just p to the fifth then. If we get rid of the variable on top, we are left with a 1 there. So it's 1 over p to the fifth written with positive exponents. Now they're showing, multiplying out all the p's and canceling, which is the longhand way. Subtract top to bottom. The other way you can do it is if you have p to the third over p to the eighth. These 3 are really going to cancel with 3 of these down here. So I will be left with p to the fifth on the bottom, which equals what we have right there, which is 1 over p to the fifth. Okay. If you look here, if you have y to the fourth divided by y to the fourth, again, you subtract exponents. So here you'd get y to the 0. Okay. Here they're showing multiplying out your y's. Each of those y's are going to cancel, and so you'd have 1 over 1 or just 1. That kind of shows you why anything to the 0 power is equal to 1. Okay, so anything to the 0 power, again, a reminder, is equal to 1. Okay, this kind of shows some more rules here, exponent rules. And if you have power to a power, which would be this rule, this shows that you multiply exponents. Multiply exponents. So a real quick example here would be When you have this, a to the second inside parentheses outside power of 3, you multiply exponents, you get a to the sixth. Okay, if you have more than one variable inside there, which you do have here, you take each of them to that power. Okay, so if I have x to the first, y to the first inside parentheses outside power of 2, multiply exponents, so 1 times 2 would be x squared. Same thing with the y, it'd be y squared. If you have a fraction, okay, or quotient, basically it says you take the top and the bottom part to the outside power. Okay, this part of it right here, when you have a fraction to a negative exponent, automatically make it a positive exponent, and you take the reciprocal on the inside. So if it was a over b, it becomes b over a. You basically invert the fraction. Okay, kind of what we did right here. If you notice, if you have x over y to the negative fourth, that basically becomes y over x to the positive fourth, which then becomes y to the fourth and x to the fourth. Okay, because it's power to a power, each of those are exponents of 1. Okay, so here's some more examples to look at. Obviously pretty basic here, power to a power, multiply exponents, and we get a to the 18th. Multiply your powers there. Now it's a little different when you have a coefficient, which we have right here in front. We have negative 2. We have negative 2. So a coefficient you have to take to that outside power. A common mistake there is that people want to multiply the coefficient times the outside power, and that's not correct. So notice we have to take negative 2 to the fifth power. So multiply negative 2 together 5 times, or negative 2 in parentheses. That gives the negative 32 right there. And then you take p to the third, which is your first variable inside there, outside power of 5, multiply exponents right here. That's why you get p to the 15th for the second part of the answer. And then same thing with s squared to an outside power of 5, multiply exponents, so it's s to the 10th. So your answer here would be negative 32, p to the 15th, s to the 10th. Again, you must take the coefficient to the outside power. Okay, if you have this problem right here, which is in letter C, you have negative 3x over y, outside power of 4. So what you need to do is you need to take negative 3x to a power of 4 on top, and then you need to take y to a power of 4. Take the top and the bottom. Now remember, that's negative 3 to the fourth power. That's a coefficient, that negative 3. Okay, and then you take x to the fourth power. On the bottom, we're just going to get y to the fourth. If we take negative 3 to the fourth power, this part of it right here, negative 3 in parentheses, that's 81. Okay, x to the fourth on top over y to the fourth. And that would be as far as you can go, or simplified there. Okay, this one right here, notice the exponent's negative, so we flip over the fraction. It's 4 over a to the third power. Then we're going to take both the top and the bottom to the third power, so it's 4 to the third over a to the third. And obviously I need to do 4 to the third power, 4 times 4 times 4, which is 64 over a to the third power. And that's what you get, and that's what they're showing you right there. This one, okay, they show a couple different methods here. You have negative 2, okay, to the fourth power. Okay, there's a variable involved here, so I have x to the 3n power, outside power of 4, so I got to take that to the fourth power. Okay, and then put it over x to the